Okay, the problem we have here says, apply the first derivative test to identify all relative extrema of the function f(x), x to the third minus 6x squared plus 12x. Now with the first derivative test, first, what we have to do is find all critical numbers. So to find critical numbers, you set the derivative to 0 or the derivative does not exist. So we'll see if we can find the derivative. So equals 0 or does not exist. Now looking at this, it looks like we can factor it and make it equal 0, so we probably won't need that. But let's just check this first. So the derivative of the function is 3x squared minus 12x plus 12 equals 0. In order to factor, we gotta take the 3 out. So 3, so this makes it x squared minus 4x plus 4 equals 0. See where I got that from? I just took the 3 out of each one. Now this looks factorable, so we'll separate the 2. There's x squared. So the 4x looks like a 2 and a 2. It's both negative, since this is negative and that's a positive. So now we just have to find the x's, and it looks like there's only one x, which is x equals 2. Since this is 0, so that doesn't count because it doesn't even do anything. And then these two are the same, so it's just 1, which is 2. So this is our critical number. So next, we have to draw a line and put it 2. We'll mark this one section 1, this one section 2. Drawing this line makes it a lot easier to determine if it's increasing or decreasing, to find the relative extrema. So for section 1, obviously that's coming from negative infinity to 2. So any number to the left of 2, we'll just do 1. Second section is 2 to infinity. We can do any number after 2, we'll just pick 3. So what you do next is you plug in these two numbers into the derivative, which we found was this. So we'll just rewrite that down here, so it's in front of us. Sometimes it's easier to use the derivative of the factored form, like this, but we'll just use this one for now. So let's do the 1. So the derivative of 1. So we just gotta plug in 1 for the x's. So 1 squared minus 1 plus 12. And that comes out to be 3. Since 3 is a positive number, that means it's increasing. So positive, increasing. So up here on our number line, we can draw an arrow up for increasing. So from the left side of 2, we know that the graph is going up. Alright, let's find the on the right side of 2. So we determined to do 3. So we'll just plug in 3 into the derivative. So plus 12. And this one also equals 3. Which is also positive, which means this is also increasing. So up here again, we can draw another up arrow. So it looks like it's just increasing all the way through. So that means both derivatives are increasing because they're both greater than 0 on the derivative. So that means there's no relative extrema. And there's your answer.